Okay, so finally on the last section of notes for chapter 2, 2.8 is about linear quadratic systems of equations. A system is basically just two equations in one that you have to solve. So normally we just solve for x, but this time with a system you have to solve for x and y. A couple of different ways you could do that. The first way we're going to go over is by graphing. So in order to solve by graphing, you just graph both we're doing ones with quadratic equations and a linear equation in one. So to solve, you graph both of them and then find where they intersect. So I'll start with the parabola. It's in vertex form. The +3, you should know by now, tells you to go to the, not to the right 3, to the left 3. So to the left 3. And then the -1 tells you to go down 1. So then the vertex is going to be left 3, down 1 from the origin. It's right here. And then remember, you need to be able to place points on either side of the vertex. Remember, it's over 1, up 1, and then over 2, up 4 from the vertex. Every single time. Over 1, up 1, and over 2, up 4 from the vertex. And then connect the dots. So there is the parabola. Now when I go to graph the line, remember how to graph a line 2. The number with the x is a slope, so it has a slope of 2, and the y-intercept is 5. So start at the 5, and the slope is up 2, right 1. Now I need to also go backwards because that's where the parabola is. So go down 2, back 1, and you're going to keep going across as much as you can so that you know, because parabolas and lines can cross up to twice. They can either cross once, cross twice, or just not cross at all. And that would be a no solution. But it looks like these do cross. So the intersections are right here and right here. So we're going to write those coordinates, and that will be the solution to this system of equations. So it looks like, let me just erase this so I have room to write it. So the solution is going to be, well, there's two solutions. One of them is going to be -3, -1. So x equals -3, y equals -1. And the other solution is going to be -1 and +3. So in other words, if I plug in a -3 for x and a -1 for y, that solves both equations, makes the left side equal to the right side. Same thing with the other coordinate. All right, now I'm going to repeat the same steps with the second example. So looks like this one has a reflection because of the negative in front, and to the right too. So then I will go start at the origin, go right 2, and the reflection, so it's going to be over 1, down 1, over 2, down 4, on both sides. There's a parabola. Now I'm going to graph the line. So start at 5, and then the slope is -2, so I'm going to go down 2, right 1. Remember, you can always make slope into a fraction if that's how you remember how to graph it. So looks like there's one intersection point. This one's pretty close, but it's a little off. And then from here, they just go farther apart. So be careful, be precise when you graph these. Make sure that you put the points for the parabola because that part's important to figure out where exactly they cross. So it looks like the only intersection was right there. So the solution then, if I write a coordinate, the solution is going to be 3, -1. That was just a coincidence that these had similar solutions. Now, remember the possibilities. You could have two solutions. You could have one solution, or if a parabola and the line never cross, like let's say you had a line that looked like this, then it'd be a no solution. Okay, so that's graphing. Pretty easy. The only problem is graphing's not good when your answer is going to be a decimal, which happens pretty often. So that's where you do a different method, for example, substitution. So substitution, you should remember from Algebra 1 2 years ago when you took that. So basically we're going to take the 3x squared plus 3x minus 5 and plug that in for y because it's a y equals right here on the front. So that's what having this y equals is what makes this method possible. If it wasn't a y equals or an x equals, you would have to rearrange the equation so that it does work. Okay, so I'll start with a 2x minus y, except I'll replace the y with that equation. So instead of the y, I'm going to write 3x squared plus 3x minus 5. Always write it in parentheses, especially for a situation like this, because in this case you have that negative that needs to be distributed to the parentheses. So then you get 2x minus 3x squared minus 3x plus 5, because I multiplied by -1, and then I have the 3 here. Now I need to solve this. Remember, to solve a quadratic equation, what number does it need to be equal to? It needs to be equal to 0. So one thing that I'm gonna have to do is I'm gonna have to subtract 3 on both sides. The other thing that I'm gonna also need to do is combine the like terms right here and right here. So I'm going to do both of those in one step. So I'll start with the -3x squared. That's done. 2x minus 3x combines to minus 1x. And the 5 minus 3 gives you 2. And now it's equal to 0. And that lets me either solve this using the quadratic formula or solve this using factoring. Now remember, factoring only works sometimes, not all the times. But this is one of those cases where factoring does work. If it didn't, just do quadratic formula. So factoring in this case, you have to multiply first number times last number. So that would give you -6. I'll write that off to the side. And they have to add to give you a -1x in the middle. So it's going to be a -3 and a +2. So split that middle term into -3x plus 2x. Bring the -3x squared down and bring the +2 down. Hopefully by now you should know how to do this type of factoring. If you don't, you really need to either come in outside of class time or watch videos online on how to factor this, because we've already gone over it in class. So split the middle term, it's 4 terms. Now it's factor by grouping on this. So factor by grouping, another one of those things that you should know how to do by now. Factor out of 3x, divide, and you have x plus 1. On the second parentheses, factor out of 2, divide, and you have x plus 1 equals 0. So it looks like -3x plus 2 times x plus 1. So for this equation on the right, looks like you can just use a shortcut x equals -1. For the -3x plus 2, you would have to set it equal to 0 and solve it. It ends up being x equals +2/3, because you'll have to subtract 2 and then divide by -3. So there are the x coordinates. We also need the y coordinates though, so that's where we have to go back and use these answers that we just got in order to solve for the y. So you can plug these x's into either equation. I personally think that the linear equation is going to be much easier, so I'm just going to use that one. You're welcome to use the other one, but it'll take a lot more work. So I'm using 2x minus y equals 3. So let's start with the -1 since that's the easy one. So plug in the -1 for x. So then you get -2 minus y is equal to 3. Add 2 to both sides, you get -y is equal to 5. Divide both sides by -1, so you get y is equal to -5. So one of the solutions is going to be -1 for the x, -5 for the y. That's one solution. The other solution is going to be, I'll do this in red so that it's kind of separate, plugging in a 2/3. So that's not going to be fun because you have a fraction. But you should still be able to do it. I mean, if you really wanted to, like worst case scenario, you can use decimals, but this one, you know how I like fractions. Makes it a lot easier for me. Okay, so multiply by 2, so that'll be 4 thirds minus y equals 3. Now, personally, I want to get rid of the fraction here, or at least temporarily, so I'm going to multiply everything by 3. When I multiply by 3, so when I distribute the 3 to the 4 thirds, that's going to end up giving me 12 thirds, which ends up being just 4. And then distribute to the y, so that would be minus 3y, and distribute to the 3, so that's equals 9. Now that the fraction's gone, now it's an easy equation to solve. Minus the 4 on both sides, so negative 3y equals 5. Divide both sides by negative 3, so negative 5 thirds. So there's your other equation, or other solution, I mean. 2 thirds, negative 5 thirds. So unfortunately, yes, these take a long time. There's no way around it. There's your 2 solutions. Next one, I'm just going to keep doing a bunch of examples so that you can kind of get the hang of it. Once you get the hang of it, that's it for part 1 of the lesson. And then I'm going to make part 2 of the lesson to be a separate video for that to be done tomorrow. But I mean, if you want to knock it all out in one day, then that's fine too. Okay, so same idea, substitution, plugging this in for the y, so then that would give me 2x minus, and then I will write the 2x squared minus 6x minus 8, and then continue the rest of the equation, so equals 16. Distribute the negatives, so it'll be 2x minus 2x squared plus 6x plus 8 equals 16. Combine the like terms. Nothing combines with the negative 2x squared. The 2x and 6x combine to give you 8x. And I'm going to have to minus the 16 anyway, so I'm just going to go ahead and do that in the same step. So negative 8. Now it's equal to 0. Now you can use the quadratic formula or factoring in order to solve this. So let's check to see if factoring works. So negative 2 times negative 8 is a positive 16. So, but they have to add the 8, so it looks like it's going to be 4 and 4. So I will split the middle term. So negative 2x squared plus 4x minus 8. So then you can factor out a negative 2x, divide, and you get x minus 2. On the second set of parentheses, you can factor out a 4, divide, and you get x minus 2. So it looks like I should have factored out a 2 in the or divided everything by 2 in the beginning. So you know what? I'm just going to regroup and do that again to make it go faster. So what I'm going to do is I can divide everything by negative 2 in this case. I should have done that in the beginning, but it's okay. So divide everything by negative 2. That gives me x squared minus 4x, let's see, plus 4 equals 0. And it looks like this would factor, this is an easy type of factoring, so that's why I regrouped and just did it. So x minus 2 times x minus 2 equals 0. So I get x is equal to 2 and x is equal to 2 for both answers. Now, when you go to solve, again, you take the x values and plug them in. So 2x minus y equals 16. Plug in the 2 for the x, so it'll be 2 times 2 minus y So 4 minus y is equal to 16. Subtract the 4 and you get negative y is equal to 12. Divide both sides by negative 1, so you get y is equal to negative 12. So there is a solution to this. So 2, negative 12. Now, here's the thing. If I plug in the other two that I got, it's going to give me the same exact answer. So this is one of those that has a repeated root. It has a repeated solution. But you only need to write it once. 2, negative 12 is the only solution to this problem. Okay, another example. I just want to show you all the possible cases that might happen. So I just went over one that has 2 solutions, then the one that we just did had 1 solution. Some of them have no solution. Kind of just depends on the problem. Okay, so plug in for y. So this would look like 4x minus, plugging in the negative 3. Notice that the order of the equations did not matter in this case. You're still plugging the y equals into the other one. And then equals 2. Again, distribute the negatives, so that'll be 4x plus 3x squared minus x, and then minus 4 equals 2. So combine the like terms. So the 4x minus x is going to be plus 3x. And I need to minus 2 on both sides anyways, so I'm just going to do that as well. So it looks like that would give me negative 6 equals 0. Now I'm not going to repeat the same mistake as last time. I see that all of these are divisible by 3, so I'm going to do that now. So you get x squared plus x minus 2 equals 0. So let's see, that would probably factor into x plus 2 times x minus 1 equals 0. So you get x is equal to negative 2 and x equals 1. So not all the problems are as bad as the first one. It was just the first one that gave a fraction, unfortunately. And then same steps. So 4x minus y equals 2. Remember, you can plug it into the other one, but that's a lot more work. So plug in a negative 2 to start. So negative 8 minus y equals 2. Add 8 to both sides, so negative y is equal to 10. Divide by negative 1, so x, or y is negative 10. So first solution is negative 2 for the x, negative 10 for the y. The other solution, we're plugging in a 1 for the x, so 4 times 1 minus y equals 2, and then you do all of that math, so I'm just going to go through that quickly. You get negative y equals, subtract 4, so negative 2, and then divide, and you get positive 2. So then the other solution is going to be 1, 2. So in this case, you had 2 solutions, and both of them were whole numbers, so that was nice. Another example, just to get you used to this. This one's a same thing. Plugging this in for the y. So 3x plus, I'm going to replace the y with the negative 4x squared plus 5x minus 8 equals negative 24. Now this one you're distributing a positive one this time, which really will change nothing. So it's just the same, 3x minus 4x squared plus 5x minus 8, nothing changed. Add 24 to both sides. Add 24. And combine the like terms. So negative 4x squared plus 8x plus 16 equals 0. Again, same thing. Everything's divisible by 4. So I'm going to divide everything by negative 4 because it's always much easier when the x squared term is positive. I'm doing this really quickly, so hopefully I'm not making any mistakes on this. So x squared minus 2x minus 4 equals 0. Looks like this is going to, let's see, if we try to do 1 and 4, or 2 and 2, one of them has to be positive, the other one's negative. So it can't be a positive 2 and negative 2. That would not work because that would be 0. And even if we did positive and negative, or negative positive with the 1 and 4, neither of these would work. So then this is one of those examples where I'm saying, since this one does not factor, this one does not have any solutions. So you'd write no solutions. Now, you can still solve this using the quadratic formula, and that would give you imaginary solutions, but no real solutions to this problem. Maybe I'll go back later on and go over what the imaginary solutions for that is. Okay, so now these are both y equals, so what you're going to do is when you substitute, this is going to substitute right there in for the y. So then you have the 4x plus 24, so this one's going to look a little bit different when you plug this in, equals, and then the other equation is the negative x squared plus 18x minus 29. Now I did these in different colors just to show you the different parts of it, but really this is all just one line, one equation that I've created by doing the substitution. Remember, I like to have the x squared be positive, so I'm going to add x squared to both sides, and therefore I'm just going to move everything that way. So I'm going to minus the 18x and plus the 29. So plus the 29, and I'm also going to add or subtract the 18x. So then what the equation is going to look like is x squared. 4 minus 18 is negative 14x. And then, let's see, that's going to be, when you add 29, that would be 53. So, let's see, would that be 17 times 3? No, not times 3. What would the factors of 53 be? So 53, 3 does not go into it, 4 does not go into it, 2, 5, 6, nope, 6 doesn't go into it, 7, divide by 7 maybe? Nope. Okay, so there are no factors of 53. So here's what I'm going to do. I'm just going to set this equal to 0 and use the quadratic formula on it so you can see what would happen in that case. So then quadratic formula, x equals, opposite of b would be positive 14 plus minus the square root of 14 squared is 196 minus 4 times 1 times 53. Then all over 2 times a, so 2 times 1. Hopefully it wasn't factorable and I just was missing a number or made a mistake somewhere. But we'll see when I do the quadratic formula. So 14 plus minus 4 times 53. So 4 times 53 is 212. So 196 minus 212 is negative 16. Okay, so then I will get square root of negative 16 over 2. Solve, so you get, when you solve this, you get 14. Square root of 16 is 4, but since it's negative, it'll be 4i over 2. So your answers are x equals 14 plus minus, well, you'll divide by 2 on both numbers, so now it'll be a 7 plus minus 2i. And then if you were to get the y, so then if you repeated that but with the y, so let's see, if I use the equation y equals 4x plus 24, plug in, let's start with the 7 plus 2i. So y equals 4, 7 plus 2i plus 24. So then you get 28 plus 8i plus 28, or no, not plus 20, plus 24. Then combine the like terms, so you get y is equal to 28 plus 24 is going to be 52. So 52 plus 8i. So there's one solution. The other solution would be if you plugged in a 7 minus 2i. So then that would be y equals 4, 7 minus 2i plus 24. Distribute, you get 28 minus 8i plus 24. And then, so combine those, you get 52 minus 8i. So then there's the other solution. So if I wrote these out, it would, one of them would be 7 plus 2i, and then 52 plus 8i. There's one solution. The other solution would be 7 minus 2i, 52 minus 8i. Now, you would not be able to just write plus minus, like write this as one set of parentheses with a plus minus for both of them, because then it's not clear which one's combined with which one, if that makes sense. Okay. I am not sure if this is what we're going to end up doing for when it's an imaginary solution. I mean, I just wanted to show you what it's possible. Like it is possible, but these are not real solutions. So I'm pretty sure you would just write no real solutions, but just in case. This one's just one more example in case you really needed to see one more of that same type. So again, plugging in the x squared plus 6x plus 5, plugging in that in for the y. So x squared plus 6x plus 5 equals 2x plus 1 minus the 2x, minus the 2x, and minus the 1, minus the 2x, minus the 1. So then you end up getting x squared plus 4x plus 4 equals 0. This one actually is factorable to be x plus 2 times x plus 2. So then x is equal to negative 2, and then plug that in. This one should be a quick one. 2 times negative 2 plus 1. Solve that, so you get y is equal to negative 4 plus 1. So y is negative 3. So final answer for this, a solution, negative 2, negative 3. That was a much nicer answer than the last one. Okay, so that's part 1 of the video. That's the lesson for today. And then I'm going to make the second half of the lesson be a separate video.